Good morning, you can hear me okay? Great, okay. So my name's Liz Rice. I work for a company called microSecurity, and we help enterprises secure their containerised deployments. And what I'm going to talk about this morning is some aspects of securing code that apply to any kind of cloud-native deployment. It's not specific to that Aqua solution at all. Hopefully some more general principles about securing code in these new kind of microservice-y, orchestrated kind of environments, where essentially you don't really know where your code is running. So let's take a little bit of a trip into history. Back in the day, people used to actually buy physical machines. Is anybody still buying their own physical machines to run their production deployment these days? We've got a couple of hands here, yeah. So, you know, this used to be how everybody did it. They used to order physical hardware, get it installed in a data center, and they owned those pieces of physical equipment. And then we started moving into the world of AWS, the world of virtual machines. So rather than owning our own hardware, a lot of us would rent virtual machines. Perhaps we're even renting whole physical machines. But we no longer have to worry about where that machine is. We might have a rough idea that it's, you know, somewhere in Virginia or somewhere in Ireland, but we don't actually know. We couldn't even get into the physical building where those machines run. In these kind of environments, these traditional environments where we had access to a machine or a virtual machine, the traditional process, massively, massively oversimplified, looks something like developers create some software, operations people provision servers for that software to run on and deploy the servers and the software. And maybe the operations people work with some security folks to agree what should be on those machines and if there are any kind of security requirements around exactly what's deployed. And then somebody would discover a vulnerability, and it would mean a patch needed to be applied to any servers, whether they're physical or virtual. So there'd be this process of having software, deploying it, having server configurations, deploying it, and then applying patches. And over time, particularly if you were manually applying those patches, there'd be sort of drift in configuration. If you had several servers, you couldn't really guarantee that they would all have exactly the same setup. You know, maybe patches get applied in a slightly different way, or it takes a long time to apply, so some servers are running different versions of code. And over time, you see this kind of drift from what you expected to be deployed to what you actually had deployed. And then this whole thing that's called DevOps happened. We started talking about infrastructure as code. We started talking about automating everything. We started talking about running code in containers rather than directly on virtual machines. We talked about continuous integration. And who's heard the term GitOps? It seems to be popular these days. Yeah, a few hands. Okay. How many people here are actually running containers? Good proportion of you, okay. And how many of you are using some kind of CI/CD pipeline? Good number of you, yeah, okay. So we have all these tools that allow us to define not just the software, but also the infrastructure and store that in code so that we can automate creating our deployment. Little sort of step back to say, you know, is this cloud native? What does cloud native actually mean? So the Cloud Native Computing Foundation, who's heard of the CNCF? Okay, not so many. Okay, so the Cloud Native Computing Foundation is part of the Linux Foundation, and it's the organization that looks after a number of projects, including things like Kubernetes, gRPC, FluentD, Prometheus, a whole load of projects related to running containers. And they describe cloud native as not just running code inside containers, but also having those containers under some kind of orchestrator, and that your architecture is built of microservices. So each microservice is running in containers. Those containers are distributed across your deployment by an orchestrator. Who's heard the term cattle, not pets? Okay, so for those of you who haven't heard the term cattle, not pets, the idea here is, so back in the sort of days when we had those physical servers, or even when we had virtual machines in a service like AWS, we knew the name of each individual machine or virtual machine. We'd treat them like individual pets, like you know the name of your dog, right? And you pay it attention and you sort of nurture it and you look after it. In the cloud native world, we need to be treating everything much more like cattle. Farmer has a herd of cattle. He probably doesn't name each individual animal. If one of them dies, well, it's not as devastating as when your pet dog dies. If a cow dies in your herd of however many cows, it's unfortunate, but frankly, you didn't really know that cow individually, and you can just get another one. So in the same way, we should be treating our containers, our virtual machines, all these entities in Cloud Native, we should be treating them like cattle. If one of them dies, so bad, we'll just create a new one. And to do this, we use these automation pipelines to build these repeatable, deployable cattle-like artifacts. Again, massively simplified, our CI/CD pipeline looks something like developers create the software, they check it into Git, or code control system. That software gets built into images, container images, there will also be machine images, and that code gets deployed. Perhaps there's some manual intervention there, but essentially the pipeline is automated. Now, security is a concern for every kind of enterprise, and a lot of people, a massive majority of people, agree with the statement that it's even more of a concern when they're deploying containers. This was from a survey by Sonatype last year. 88% agree that security is a concern when deploying containers. And it's not really that surprising when you think about it. You've got some cluster of machines with all these containers running somewhere. You could have hundreds of different microservices. That's very typical. And each microservice could have several instances, so there could be thousands of containers. The average lifetime of those containers is only around 2.5 days. So these things are coming up and down all the time. And each one of those containers has its own set of dependencies and libraries. So all these thousands of instances, all with these dependencies and libraries, which could all contain vulnerabilities. So this is, at least at face value, it seems like a complete nightmare. How on earth are you supposed to patch all of those containers? How are you supposed to know which ones even have vulnerabilities, let alone keep up to date, when that container is only there for a couple of days, and then before you got a chance to patch it, it's gone and it's been replaced because it's cattle. And the answer is you don't. You do not apply patches to individual containers. You don't apply patches to container images. Instead, you apply those patches as part of your automation pipeline. Oops. You create your software, you build images, those images are immutable. They never change. If you need a change in that image, you're going to rebuild it from scratch. So that what you deploy, what's running in your system, is always the output of your build pipeline. Never modify. We're always moving sort of from left to right in this pipeline. Now, we might not always get all the way through that pipeline. You might, for example, want to scan for vulnerabilities. There are lots of different solutions for container image scanning out there. Aqua is one. There are also some freely available scanning services out there. And these scanners take a container image, so the output of a Docker build, and they inspect it and compare it against known databases of vulnerabilities. And you can be scanning your images during the pipeline. You may want to scan at the point just before you deploy software. Essentially, make sure you're not deploying something with a high impact vulnerability. And you might also want to be scanning continuously scanning the images that are deployed. You have software. The world of research or security research is finding vulnerabilities all the time, and it's very possible for a new vulnerability to be found. So even though you don't change your code, you don't change your dependencies, a new vulnerability could affect you. A bit like, a couple of months ago when Meltdown and Spectre were announced. A lot of people, were suddenly discovered that they were affected by these very severe, impactful vulnerabilities. And in a containerized world, an image scanner would tell you these are the images that are affected by that vulnerability. You can also implement image policies through your pipeline. Again, I mean, this is something that Aqua does, but there are other tools available, and things like Kubernetes have things like admission controller hooks that can help you with this. And your image policies allow your organization to to set rules around what you're allowed to deploy. So, for example, you might say, we're not going to deploy anything with a high severity vulnerability. Or all these vulnerabilities have these kind of conventional scores to indicate how impactful they are. You might say, we are only going to deploy images that have a score below a certain level. Or we might have certain images that we've whitelisted. There might be vulnerabilities that our security teams have looked at and said, actually, that vulnerability, although it's present in the library, doesn't actually affect us. It for whatever reason, can't, we'll take the risk on that one. So your individual enterprises might have very tailored image policies around what they're going to allow to be deployed into production. You might also have rules around the base image. So if you're building a Docker image, you start from a particular image. And a lot of organizations will have a sort of standard version of the base image they're going to build from. Maybe they have standard versions for different languages that developers are using. Does anybody here work for a company that has like a standard base image that they have to build from? Yeah, a few hands. Yeah, I think as we see more enterprises adopting containers and kind of maturing those processes, I think we will probably see more of that where the organization will have some rules around what those base images need to be. And that's, again, something that you can police as part of your CI/CD pipeline. I'm going to build my image. I'm going to check that it's built from one of these approved images, and I'm going to check that if it has any vulnerabilities, those comply with the rules that I've set up around what I'm going to be prepared to have running in my production environment. So now we have all these containers running distributed across this big cluster, and we don't know where each individual container is going to be running. We still have all these hundreds of microservices and thousands of containers, but at least we know all those containers were running from approved images. And if we learn about a new vulnerability, we have to redeploy those images, and we do that using the CI/CD pipeline that we have. So we don't have to go around and patch individual containers. We just kill them because they're cattle, and we can just replace them with new versions. Okay, so that kind of explains how we can handle the container images and the containers that are running. But that software is also running on a virtual machine, or perhaps a physical machine. And those virtual or physical machine hosts are running software, and therefore that software could have vulnerabilities in it. So there are a few things that we can do in a cloud-native environment to help us secure those hosts, the software on the hosts, or to make it easier to address any vulnerabilities that come up. So the first thing is there are some kind of customized, dedicated versions of Linux operating systems that are designed for running containers. So things like Red Hat's Atomic, CoreOS, or the container Linux. Well, I guess we don't really know the future of that one yet. There are a few of these out there that Rancher as well has. They're like a cut-down version of Linux where you don't need every single feature. You don't necessarily even need desktop software on your hosts. So if you don't install it, you have a smaller attack surface. So good practice to use one of these base operating systems that's designed for containers. You can run automated testing on these hosts. So imagine we have all these virtual machines, and maybe they're running software like Docker, they're running an orchestrator like Kubernetes. And there are tests that you can run to make sure your Docker settings are appropriate, sort of best practices for security. Same for Kubernetes. There's an organization called the Center for Internet Security, and they publish guidelines. Has anybody heard of them? CIS? Couple of hands, yeah. So they publish guidelines for how to configure software for sort of best practices around security. Things like if you're running a mail server, don't just leave all the ports open unsecured, that kind of thing. And they've published a couple of relevant guidelines for what we're talking about today. They've published a spec for Docker, and they've published a spec for Kubernetes. And there are tools. I personally worked on a tool called KubeBench. I'll share a link to it later, which is an open source tool that you can run on your Kubernetes machines, and it will tell you whether or not that machine is configured in accordance with those CIS guidelines. If you kind of regularly run tools that test the settings on your host, that can help you make sure it's not drifting, that it's exactly how you wanted it to be, and that the security settings are good. Now, I talked about cattle rather than pets, and I talked about how we should be able to kind of rebuild all our software and redeploy it, whenever we choose. And we can apply that to the servers as well as the containers. So essentially, every so often, a server that's been alive for however long, we just say, you know what, take that away, replace it with a new version, redeploy it. Why do we want to do that? Well, if there has been some kind of drift away from what we originally deployed, we're going to throw away that drift, and we're going to go back to what we really expected that server to look like. So we're redeploying the kind of canonical defined version of that server's software. Why would that server have drifted? Well, it might have drifted just because of, manual intervention. Maybe somebody in your team did something crazy, like SSH directly into the machine. People can do that. You shouldn't, but people can. Perhaps your server has drifted because an attacker has got into it. Perhaps you didn't even know that one of your servers has been compromised. If you do suffer an attack, there's some finite amount of time between the attacker getting onto your machine and the attacker being able to do something like export all your private user data somewhere. It takes some amount of time for them to figure out, once they've got onto your machine, how to get hold of that personal information and how to exfiltrate it. If you do something like recycle the host before they were able to exfiltrate the data, great, you pull the rug out from underneath the attacker. You have prevented that attack from doing anything damaging to your business. So recycling the hosts could help you in the event of a compromise that you didn't even know had happened. And then finally, there's lots of traditional security tools out there, like firewalls and intrusion detection software. And there is absolutely no reason why you shouldn't carry on using that. That's kind of a border around your cloud-native deployment. There's actually an argument that intrusion detection is more effective in cloud-native environments. As I understand it, this works because intrusion detection looks at changes in the server file system. And when you're running containers on a host, the changes related to the container, maybe the container is storing state somewhere, it is making changes to files, but they're limited, they're within that container's own little section of the host file system. So it's easier for an intrusion detection system to see changes, to spot drift, to spot potential attacks, because the range of normal file changes is pretty small. They're limited typically to just what's going on inside the containers. So those intrusion detection tools could actually be working more effectively in your containerized deployment. Okay, so we talked about securing your containers. We've talked about securing your host operating system and how in both those cases being containerized can actually help you because you've got these automation tools. You can leverage that to make it easier to secure your deployment. But there are additional advantages to using kind of cloud native, to using microservices. One of them is reducing your image size. If you've got a container image and somebody somehow gets into a container based on that image, they can run software that's inside that container. And if that container has only a very, very small amount of software in it, there is less that an attacker can do. It's essentially a smaller attack surface. So on the right here, I've got a kind of extreme example of a very basic container image, or the Docker file that would build a very basic container image. It starts from scratch. That's literally an empty file system. And it's adding a binary executable and some templates that binary needs. And that's all that's inside that container. If somebody gets inside that container, all they can run is the hello executable that was supposed to be running anyway. There isn't any networking tools, for example. There's no SSH, there's no ping, there's nothing that they can execute from inside that container to explore the world that container is running in. So we basically rendered that container pretty useless to an attacker. He shouldn't be able to get into it, but if he did, there's not a lot he can do from within it. And in general, you really don't need very many tools inside your container images because you shouldn't be manually accessing. Maybe during development there are things you want to do, but for your production containers, you don't need access to them. If anything goes wrong, you want to be exporting information in the form of sort of observability, but you shouldn't be accessing those running containers manually. So you don't need many tools. If you can reduce your image to the code that you need to run and its dependencies and nothing more, that is a safer piece of code to run. And this is much easier to do in a kind of microservices environment because well, it's not a big monolith with like a gazillion dependencies and a gazillion tools that you might need. Another thing that is easier to reason about with microservices is the connections between them. Which microservice should talk to which other microservice? What database access should it have? If you've got a complex piece of software, it becomes much harder to reason about like what that software should be allowed to do. What do all the error cases look like? What's sort of reasonable behavior? But for microservices, if you've really cut things down to small, simple pieces of function, it's much easier to reason about what network traffic should be allowed. Should container A be allowed to talk to container B? Well, maybe yes, but it shouldn't be allowed to talk to container C. We can also encrypt the connections between them so that if an attacker is somewhere in your network, they're not able to kind of intercept or interrupt or interfere with those communications between those microservices. And there are tools to do that. There are projects like Istio, service meshes in general, that can help you with this kind of encrypted connection. And along similar lines, if we can reason about what network traffic should be allowed between different services, we can also reason about what actual executable behavior is allowed. There are tools like seccomp and SE Linux and AppArmor that can restrict what your executable is allowed to do. And then there are also commercial tools like Aqua. This on the right-hand side, that's a screenshot from a little bit of Aqua's tool, where we've essentially detected a container running curl when we have said that actually curl should not be allowed. It's not one of the permitted actions from within that kind of container. And if you can lock down what is allowed to execute inside a container, again, we've made it harder for an attacker to do something. There's less, maybe they're trying to use curl to get data from another container, but they've not been able to because we've blocked that action. And I'm going to sort of demonstrate the principle behind this by looking at a vulnerability called shell shock. Who's heard of shell shock? Yeah, quite a few of you. So this is it's I think maybe 3 years old now, but it serves to demonstrate the purpose. Okay, so if I'm lucky, yay, my shell shock little server is still up and running. So this is it's basically a version of Apache which has the shell shock vulnerability within it. And I can let's go back here. And hopefully, so this is my, I'm going to serve the home page first. So it's just an Apache page, and there are some CGI pages inside this deployment. So CGI is like a sort of the old way of building dynamic pages. In this case, there's not very much dynamic about it, but when you run the CGI page, you are executing code on the server. And we can see that in practice. So what I'm going to do is I'm going to run another container. It's called Tracer. And with this PID line, I'm afraid it's split over 2 lines, but I'm going to attach to the process ID namespace of my shell shock container. And I'm going to use a tool called ptrace, well, strace really, but to run strace, I need a capability, a Linux capability called ptrace. Don't worry about this too much if there's a whole other talk we could do about that. And my container image that I'm going to run is running Ubuntu with strace installed. and I'm going to run a shell. Okay, because I've got the process ID namespace shared with Shellshock, if I look at the running processes, I can see my own shell, but I can also see what's going on in that Apache server. So I've got an Apache service and a few of these HTTP daemon processes running. And I'm going to trace what's happening with them. I want to know if we fork, the -f says follow if we fork a new process. I am interested in a system called execve. So what strace does is it logs out the system calls that are being made by a process or a set of processes. I'm only interested in a system call called execve. And I want to trace these HTTP processes, 27 and 42. I think that's everything I need to do. Okay. So if I were to curl to, I think it's 8080 from here, and I run that CGI page. Right, so we can see this is the page we were just looking at, just the sort of raw HTML output. And when I executed it, a process got forked. That's what execve is doing. It's forking and execing a new executable. And the executable that it ran was this hello CGI script. Okay, so now I am going to attack that container. See if I can remember how to do this. Agent. And I am going to run, I think it's like this. I'm going to run env, and I'm going to pipe the results into a page that I'm going to call env.html. And before I actually run that, I'm just going to demonstrate that there is nothing there at the moment. Yeah, so it might be a little bit small to read. Let's make that a bit bigger. There is no env.html page available at the moment. But if I type this in correctly, let's hope, we got back an error page. Well, that's fine. I'm attacking the thing. I don't really care if I see an error page. But over here, we can see not only did we run the CGI script, but we also ran bash, and that ran env. And if I go back here, as an attacker, I have been able to get the results of env. I mean, that was just a sort of an arbitrary command that I happened to run. But now, as an attacker, I've got some interesting information about this particular machine. I could probably do some much more interesting and difficult and devastating things to this deployment now. I've been able to do that because the Shellshock exploit lets me run code like this, arbitrary code, when I run a CGI script. Now, the point of showing this is not really to show you the Shellshock exploit. The point is to say, normal behavior said I could run the CGI script. Normal behavior did not expect me to be running bash, and it did not expect me, definitely did not expect me to be running env. Apache is not like a beautiful, modern, small microservice. But even here, with this relatively sort of monolithic code, we can see how if we were able to limit the set of executables that we can run inside this container, that could be pretty useful. If we were able to say, actually, you know what, if we see env, if we see somebody trying to run env, we don't want that to happen. That should not be permitted. That would be a really useful thing, and that would help us to prevent attacks. And if we could rewind, 3 years or whatever before Shellshock, even if we didn't know that Shellshock existed, even if we didn't know what the vulnerability was, what the mechanism was, if we were just able to say, here's the set of executables that this microservice is allowed to run, anything else, red flag, don't want to see it, bad news. That would be a really, really useful thing. You can use tools like setcomp to limit the set of system calls that you're allowed to run. You can use AppArmor and SE Linux to limit sort of more complex combinations of like which files you're allowed to access, which system calls you're allowed to run. And you can also use commercial tools such as Aqua. And if I go back to that previous, come on, there we go. If I go back to that previous slide, that was exactly what we've done here. We have spotted an executable that shouldn't be allowed, and we have prevented it from being run. So that's kind of the sort of extra protection you can get from runtime protection tools. So, cloud native, I actually firmly believe that if you're running microservices under orchestration, you have some advantages over a traditional deployment. We've seen how using microservices allows us to decompose. It decomposes our architecture. It gives us lots of advantages architecturally, and I'm sure that will be talked about over the course of the next couple of days. But it also allows us to decompose the security problem. We can look at these individual services and make reasoned decisions about what they should be allowed to do in terms of execution, in terms of network profile, in terms of file access. And we can use those to sort of build up layers of defense. And that's in addition to the defense that we had in a traditional deployment. We can use this kind of principle of cattle, not pets, and the fact that we have all these automation tools to automate redeploying code and redeploying servers, which helps us limit the attack window that, or the amount of time that an attacker has to run their exploits. I think also, conferences like this, meetups, open source software, all that predates cloud native by many years. But I think it's true to say that the kind of the cloud native world, the modern software world, the DevOps movement, we see a lot of community sharing of best practices. We see a lot of idea sharing. And whether we're talking about open source software or commercial tools, we're much more able as communities to kind of get together and share our best practices and share our ideas and how things are working well within our organizations. I think all those things help us to create more secure deployments when we're running microservices, when we're running cloud native. Not that, I'm not saying that everything is solved, that, that security is always going to be an arms race and there will always be room for improvement. We did a survey at the end of last year, and 80% of the enterprises that we spoke with agreed that there was room for improvement in the security of their containerized deployments. A couple of quotes from the Enterprise Strategy Group. So containers, when you're running containers, you need more collaboration. Again, I'm sure this is something that will come up over the next couple of days. We need security experts to be working in collaboration with DevOps teams to help figure out, when we've looked at those pipelines, what those image policies are going to be, what scanning tools we're going to use, how we're going to protect the overall environment. We can't just apply security as an afterthought now, which kind of often used to be in the traditional world. Security needs to be sort of built into the process all the way along. Organizations would do well to embed security early into the process. Now, this one, I think you can read this in two ways. Does it mean embedding security early into the CI/CD pipeline? I hope it does. The quicker or the earlier in the process you can excise a vulnerability, the better. You want to find those vulnerabilities before you deploy your software, not after it's been running in production. But I think it's also talking about that idea of collaboration, that you want to engage with security as you're setting up your CI/CD, your automation, your GitOps practices. Think about how security is going to work within those pipelines. There's lots of tools and lots of information out there to help you with that. So we talk about continuous integration and continuous deployment. We could also be talking about continuous security. And I think in the cloud-native world, continuous security is really important. A couple of links. That survey I mentioned, if you want to download a copy, there's a little form you can fill in, and then you get the results of that survey. It's not the questions, it is the results. And then also on GitHub, there's the Kubebench tool that I mentioned, which enables you to run those CIS tests on your deployments. And with that, I think I have about 8 minutes left. So if there are questions, let's do questions. Oh, and also I will mention I have got a few Aqua stickers. So particularly if you ask a question, you can definitely get a sticker. And other people can come and ask me for a sticker as well. OK, questions? Somebody must have a question. They're really nice stickers. Yes, there's a question. Somebody's going to get the ball rolling. Yay.
Thanks, there's lots of things to think about there. If I had limited resources, which is often the case with clients, where should I focus my efforts first? On the assumption we are using, say, something like Kubernetes and Docker,
right.
Where do you think I'll get the most value first, I guess?
I think from a security perspective, the image scanning is the biggest bang per buck. And it doesn't have to be a commercial tool. It could be, like Quay have their open source scanner. I think that's probably, it helps you across your whole deployment. It's something that is almost impossible to do manually at any scale. And, that it's going to help you not have those really serious vulnerabilities. So yeah, that's definitely where I'd start. Any more questions? Yes, there's one there.
Do you know of any tool that makes it possible to actually scan the image when you're doing the Docker push? So it basically gets declined when it's not fulfilling all the security requirements?
So I guess one way you can do that is in your, let's say, your Jenkins pipeline or what have you. You build the image, you scan it, and then if the scan fails, you don't do the push. So rather than it's not exactly in the middle of the Docker push, but it's immediately before the push. That would be pretty common. Another one at the back there.
Yeah, I would have rather politically not correct question because it's related to all enterprises. How would you recommend us to address the security issues when we don't have any security team and we are just, learning by doing this stuff with containers, with security? How would you address this kind of stuff?
Oh, yeah.
Because we don't get any recommendations at all. We're just learning by doing.
I think it's not uncommon, and I think we can see, particularly in the world of Kubernetes, where security is improving all the time, but people have been using Kubernetes in production with some pretty insecure setups. I'm going to use as an example etcd. So all the state from Kubernetes is stored in an etcd database, which by default is not encrypted. And that may or may not be a problem for you, but it's probably a pretty bad idea if you're storing credentials inside etcd. I did a talk at CNCF meetup last night about secrets management in general in containers. And it's one of those things where people have just been happily, running these clusters completely oblivious to the fact that their etcd database is it's got all this secure information, just base 64 encoded. And the community, the people who are working on Kubernetes are addressing this stuff, and the situation is gradually improving. But I'm sure you are not alone in having teams that are working with these tools who aren't security experts. For a lot of people, and I came from a development world. My background is not security, and I definitely thought, yeah, security. There's a whole load of mysterious dark arts that people know about that I don't know about. Actually, it turns out a little bit of education, a little bit of research. You don't have to know all the ins and outs of how they've detected these exploits. You don't need to know all the ins and outs of, I don't know, how shell shock works, for example. What's more important from a sort of DevOps perspective is knowing things like, okay, scanning tools exist. Okay, how can we add that into our pipeline? Depending on your organization, obviously, I work for a security company. We help organizations with this stuff. So for, banks and large financial institutions and large media organizations, they're coming to people like us and our competitors and getting advice that way. And I think also a lot of the, the companies that are helping people, the sort of consultancy companies that are helping people set up their Kubernetes, their containerized systems, their CI/CD pipelines. There's a lot of people out there who are, they'll charge you money, but they will help you. Sorry, another question there.
I would have another extra question, but how would you convince those people who actually thinks that it's secure enough to set, I don't know, secure values via environmentals, and that the microservice, with the container with the microservice is not speaking directly to internet, but it's only accessible via load balancer, and they think that's kind of enough.
Right.
But you don't also think that's secure enough, right?
Secure enough is always a bit of a, depends on your context, right? If you're my bank or you're my doctor, I'm not happy, If you're hosting my WordPress blog, maybe I'm not that bothered. There's going to be levels of security requirement, that depend on your application. How do you convince people that perhaps they need to be addressing security a bit more often? I guess talks like, you come to this, and hopefully I've set the fear of yeah. There is lots of content out there that talks about this stuff. You only need to look at tech news around things like, Meltdown and Spectre and all these other vulnerabilities. A really great example was Tesla the other day, who the exploit was barely an exploit. All they had done was they had left the connection to their Kubernetes dashboard open to the world. Didn't need any kind of credential, and it's really easy to do that. For years that was the only thing you could do. You can now secure your Kubernetes dashboard, but it's so easy to just have it running, and you don't realize that it's open to the world. So you could maybe use those kind of quite public exploits as examples to say, look, if it happens to Tesla, perhaps there's something we should look at too. Hope that helps. I've got 1 minute left by the looks of it, so any last question to fill that 1 minute? Okay, you can fill that minute with a spectacular round of applause instead. Thank you.